welcome to Fatima Norm Academy. Today we will be talking about lesson 2.2, normal distribution. Okay, so to start off, as you can see, this is a good description of real life data such as SAT scores. We see the graph on the top right hand side. This tells us where the mean is, where the inflection point is, and where the standard deviation lands on each part of the graph. And then on the bottom left corner, the empirical rule, you see how the graph is split in the middle, and on each side we see the reflective percentage points that stay the same. You might want to memorize them as they stay the same in each problem that has to do with normal distribution, as well as you can see where the mean changes and how it changes based on the standard deviation of each one. Because the graph or the curve is symmetric, we know that the percentages fall equally on either side. That is why the percentages are the same on both sides. The values at the bottom will also most likely be the same on the right as the left, but the left will be the negative. To begin practicing, we will use this question that reads 2,000 freshmen at State University took a biology test. The scores were distributed normally with a mean of 70 and a standard deviation of 5. Then we label the mean and use the standard deviations from the mean. This will technically be the first problem in normal distributions. So then you would make the graph or the table on the bottom and use the percentages that I talked about in the last slide to divide up the graph. And then we use the mean, which is 70, and then we add 5 to the right and subtract 5 to the left to figure out our mean. When doing normal distribution problems, you do have to remember that on the bottom side of the graph, which is 34 plus 13.5 plus 2.35 plus 0.15 does add up to 50%, as well as the right side adds up to 50%. The next slide, you will learn how to use standard deviations and percentages to figure out statistics test. I know that this next slide looks a little overwhelming, but just take it problem by problem. First, we're going to start with question A that says what percentage of scores are between 65 and 75. So you would look at the table at the bottom and just look at where the 65 is and then the 75, and what you're going to do is you're just going to add 34% plus 34% because that is what lies in between those percentages, and that gives you 68%. We're going to skip question B just because they're very similar to question A. We're going to move on to question C that says what percentage of scores are between 60 and 85. So you will basically just do the same as we did in question A. You're just going to add 13.5 plus 34 plus 34 plus 13.5 plus 2.35, which gives you 97.35. As you can see in the graph, those are just the numbers that lie in between the scores of 60 and 85. Moving on to question D, it says what percent is less than 55. You just look at where the 55 is and then look at the number that's under. That would be 0.15%, and that would be the amount of scores. For E, you would do the same thing as we did for D, except you would look at the right side of the 80%, which you would just then add 2.35 plus 0.15. F is a little more of a tricky question as it is asking for how many instead of a percentage. For that, you would just add the percentages still, and that would give you 47.5 of the 2,000 students because that's the amount of students that we have. And then you will just multiply the 2,000 plus the 47 because you moved the decimal, give you 950 students who scored between 60 and 70%. For G, we would use the same method we used in F. You would first add the percentages that are between 55 and 60, and then you would just multiply that by 2,000, giving you 47 freshmen. I hope that made sense. For these questions, all of the following questions are based off the main question that reads 500 juniors at Central High School took the SAT last year. The scores were distributed normally with a mean of 24 and a standard deviation of 4. We just label the graph as we said before. You have to do it for every question so it is easier to solve. A reads what percentage of scores are between scores 20 and 28. And I know it looks kind of scary, but we just use the same method. For this one, you just do two operations. You first find the scores between 20 and 28 by adding the 34% plus 34%, which gives you 68. and then you just put 68 over 100 times x over 500, since that's the amount of students who took the SAT, giving you, and then you just use algebra to solve and gives you 340 students approximately. Question B is very similar to A. You just do the same thing. You add the percentages on the graph that are in between the two percentages, which is 16 and 28, giving you 81.5. And then you just use algebra again to solve it. Use the equation. And then you just get 807.5 juniors, I believe. For C, you would just look at all of the scores that are less than 12, and then that would be 0.15, and then you just do the same thing, use algebra to solve. That would be about 0.75 seniors. Sorry, I meant juniors. For D, you would do the same thing, except you would look at the score that is to the right of 32, which gives you 2.5%. Then you use algebra, which you get 12.5, but you round down to 12 because obviously there is not 12.5 juniors. And then as you can see in E, you just use the same thing that we learned. You add the percentages, giving you 95% of juniors, which scored between 16 and 32. Then in F, it asks you for the amount of juniors instead of the percentage, so you use the algebra equation. So finally, to finish off, we have the key takeaways of this lesson. Beginning with the most simpler part of just finding the percent of the population that is asking you, you just make the graph and then you add the percentages to the graph that we talked about. Again, 34%, 13.5%, 2.35, and 0.15 on each side. The values should be the same for the percentages, and then you add the bottom using the mean and the standard deviation. You either subtract or add it based on the side that it is at. Finally, you add the percentages of the numbers that you are giving in the problem. For example, we had like 65 and 70% of students. Now, to find approximations when it is asking you for a certain number other than the percent, you use the same thing that we did in the first part of adding the percent, and then you just create the equation, which is the percent that you have found of the graph, and then you put it over 100 times x, which will be the number that you are solving for, and then the bottom is the n, and it is the total population that you have. That will be it for today's lesson about the normal distribution and finding percentages, as well as the actual approximation. Thank you so much.